Hey there everyone and welcome to another lecture of the SolidWorks series. In this lecture we are going to cover one of the very important section in any of the software. So it's not limited to a SolidWorks only. We are talking about the concept that is very important in any of the CAD software that you are going to study or that is available in present or it may available in future. So any software that is available, this concept is very important. And what is that concept? It's a concept of constraints. So basically we are going to talk about the dimensional and geometrical constraints. So before moving on to this dimensional and geometrical constraints, we are going to learn about what is constraint. So if I'm going to talk about the constraint, so constraint is anything that is tends to stop the body in going or in creating that motion. So let's say we have one nut bolt over here like this. Let's just imagine this to be as the bolt, and we have this nut over here. And if I'm not going to put this nut over that shaft section of the bolt, you can just move this nut anywhere you want. Like I can just put this nut over here, I can just put this nut over here, and I can just put it this nut over here as well. So now what I have done, I have just pounded this nut over that shaft like this. I have just tightened this one. So now the motion of that nut is very much constrained. You can just only move this nut over the shaft like here in the left or a right direction like this. You can't able to move your nut over here or anywhere uh, randomly, because that is now being constrained. Similarly, if you try to just lock a person inside a room, then that person is very much constrained inside that room. It can't move anywhere beyond that room. It will only have the limit till that room. So that is the definition of constraints. You are just constraining a body to have the free motions, and you only want your motion to be desired, and you only want your motion to be more focused. So that's why you provide constraint to a body. Here also this dimensional geometrical constraint is very much important. We are going to learn about these constraints in 2D and 3D both. Since now we are creating the 2D sketches, so we are going to see this concept in 2D. So before moving on to this constraints and dimension geometrical constraint on the software, I'm going to provide you one very good example. So for that, I just have to start my sketchbook. And let's just imagine this sketchbook book to be a field of grass that is having infinite value. This field is not limited, it's an infinite uh, vast field. So now we are just keeping one cow over here like this. So I am very bad at diagrams. So just compromise this. Let me just have this as my cow. Oh, it's become quite good. So this is your cow. It is looking like a turtle more, but just imagine this to be a cow over here. And now what my point of view is that this cow is going to eat this grass, and it can be anywhere on the field. This cow is not constrained. It can move anywhere and have his grass, his her grass. You can cow can be over here. The cow can be over here as well. She can be over here. She can be over here as well. So it is not bounded. The cow is basically not bounded to one desired position because we don't provide any constraint, or we haven't provided any constraint to this cow. So its motion is very much free. So this kind of motion of cow is known as a unconstrained motion. So you can see that the cow is performing a unconstrained motion. Then what I have done, I have just provided a rope along and his neck, her neck, sorry, and we have put that rope over here. We have not fixed that at the other end to the ground. It is just on one end and it is on her neck, this point is free. So right now also the cow can move anywhere whether she wants with that rope. It means that this rope is not having any effect on the cow. The cow is still moving anywhere she wants. So this kind of arrangement is known as under constrained arrangement, because we have provided one object to constrain this cow, but their arrangement is not enough to just limit this cow. So this is known as the under constrained motion. Now, what I'm going to do, I'm going to fix this end to the hook in the land like this. So now what is happening? The cow is very much fixed now. It can't able to move anywhere. It can only able to move along the radius of L length. What should be the length of this rope? It can only able to move along that radius. Let's just make this length to be 10 meter. So it can only move in the limited area of 10 meter over here. You can just draw this 10-meter circle. So now this kind of arrangement is known as completely constrained or successfully constrained or defined, fully defined motion. So we have now been limited this cow, and this infinite field is having no effect on the cow now. Now what I'm going to do, I'm again going to provide one rope over this cow's neck, and it is also having the length as 10 meter, and it is also fixed to this end only. And this is also having the length, as I've told you that this is also having 10-meter length. So now you can assume or you can imagine that this will have no effect on the cow's motion. It will only show that motion which we have provided when it is fully defined. So this kind of arrangement is known as over constraint. It means that that length or that rope is not required for its motion, but still we have provided this one so that uh, for any other purpose, I don't know the desired purpose, but we have provided another same length of rope, so that is not having any effect on the motion of the cow. So this is condition is known as a over constrained condition. So now we have learned about three conditions. One is unconstrained, when there is no foundation to a cow or there is no foundation, it can freely able to move anywhere on this infinite field. Then we have under constraint. It means that we have provided one dimension, or we have provided, or we tried to provide one constraint, but that was not enough to constrain this cow on its place. So that was known as underdefined. Then we have provided all the things that is required to just keep this cow on its desired motion that we want. Then that was known as successfully constrained or fully defined. Then we have again provided one more rope, and that doesn't seem to have any effect on the motion of the cow. Then that is known as over constraint. So these are the types of constraints that you can see in software as well. Now here, what is dimensional and what is geometrical constraint? So here this cow is acting or behaving as one geometry, since it is completely one geometry. This rope is behaving as another geometry, and this hook is behaving as the third geometry. And here we can see that the whole effect is done with the combination of these three geometries. So these three geometries are known as geometrical constraints. We have this rope as our geometrical constraint of geometry that is providing that constraint. So this is known as geometrical constraint. Now what is dimensional constraint? The cow can only move on the radius of 10 meter, and that is because of the length of the rope that is to be a 10 meter. So that loop is limited to some value, its length is limited to one value, and this value is 10 meter. So this 10 meter is a dimensional constraint of the rope. So just like the cow, to constrain anything on the object or to constrain any of the object on the sketch, we just required these types of geometrical and dimensional constraints arrangement. And later on, in the further lecture, I'm going to provide you how we can able to use this constraint value in the software. But you can just go for this definition of the constraints from the different lectures and different sources like internet and all, but you can't able to find this elaborative and simple example of this constraints option. I have just provided you this value and this example, and I just assume that all of you have easily able to grab this concept. In the next lecture, we are going to see these constraints on the software. So that's all for this lecture, and I'm going to continue in the next one.